Welcome back. In this video we're going to have a look at some basic techniques for factorization. Factorization being the process of taking an expression from its expanded form and moving it back into its factorized form, or its form with brackets. Now looking at example 1, we've got 3m plus 27. Our objective here is to make it such that we're going to get a number, so we don't know what it is, x plus something inside. Now, how do we do this? Well, we have to factorize. Now, what does that imply? Well, the easiest way to think of it is we want to see what's common between this number, or this term, and this term. Now, simply looking at it, the easiest way to do it is you ask yourself, is the bigger number divisible by the smaller number? So 27, can it be divided? And what you'll find is if you divide it out, it's actually going to fit into it 9 times. Or another way to do it is you can simply write all of these guys out in terms of their factors. So I'm actually going to take the second route. I'm going to write it as 3m is simply 3 times m plus, and then we've got this 27 here. So 27, the factors of that are 3 times 3 times 3. Now what we do is we look at what is reoccurring, and in this case the reoccurring numbers are the 3 here and the 3 here. Notice that there are 3's here and here, but we've only got one 3 at our disposal on the first term. So now that we've got that, what I'm going to do is I'm going to take the numbers that I've underlined and I write them out like that. Now I open up a bracket and I'm going to write my m plus 3 times 3. Simplifying that up, I get 3 times m plus 9. And that's a really, how should I put it, probably a very structured way of doing factorization. Now there are more efficient ways to do it, but this is a way such that you're going to collect all of the most common factors between the numbers simply by breaking it up into its prime factors. Alright, going across to number 2. We're posed with another problem. We'll use the exact same method that we used over in number 1. We're going to break 16i minus 12 up into all its factors. So the factors of 16 are simply 2 times 2 times 2 times 2 times I minus, and then the factors of 12 are 2 times 2 times 3. Now we're going to look what's common between the two. We've got a 2 here, 1 here, 1 here, and 1 here. So now that we've found everything common between the two, we write it as 2 times 2, open up our brackets, then 2 times 2, so the guys left over, times I, minus 3. Now, bringing everything back together, we get 2 times 4, or 2 is 4, then 2 times 2 is 4i, minus 3, and thus we're in our factorized form. So if you expand this out, we'll get 16i minus 12. So nothing too simple or too difficult just yet. Alright, going over to 3, we're going to use the exact same method as before. So what we'll do is 12 is going to break down into 2 times 2 times 3, then it will be times j times j. Now we've got this minus here, and I'll just I'll move this guy down to get a bit more space. That'll work. Alright. Dealing with this other term, so minus 32. The factors of 32 are 2 times 2 times 2. So 2, 4, 8. 16, 32 times j. Alright, now we're going to underline what's common between the two. We've got 1, 2, 1, 2, then we've got 1j and 1j like so. So bringing that together, we've got 2 times j. Then we've got this 3j left over on the first term. Take 2 times 2 times 2 times j. Actually, no, not j, because we took it Too easy. Now, multiplying everything back together, that should, we get 4j minus, or times 3j, take 8. And thus, if we expand this out, we find that we get 12j squared minus 32. So we know that's the right answer. Now, alright, question 4. 12n to the power of 8 plus 9n to the power of 5. Alright, now with this question, or I should say in the last questions, I've broken everything down into its prime composites, or its prime factors. In this one, I'm not going to do it. In this one, we're a little bit more learned, and we're going to take one step forward, and we're going to look for the biggest factors between the numbers. So for 12, we know it's 2 times 2 times 3, and that will give us 12, and 9 is 3 times 3. But if we look at 12, we know there's a factor of 3, and we don't really care about anything else because the common factor between the two is, or the largest common factor between these two numbers is 3. So the way in which I'm going to break this down is I'm going to write it as 3 times 4, and then looking at the n to the 8 and the n to the 5, the common factor here is n, and there's 5 of them in common. So I'm going to write times n to the 5, and then I'll do the leftover 3 like that, plus, then I'm going to go 3 times 3 times n to the 5. Now, everything's in a nice form such that we can go through and we can highlight what's common. So we've got a 3, n to the 5, n to the 5. So bringing it down to a new line, we get 3 n to the 5, then in brackets we leave behind this 4 n to the 3 plus 3, and we're done. So if we expanded this out, what we get is 12n to the 8 plus 9n to the 5. So this is just a really nice way, or a simpler way, of factorizing without having to break everything down into its primes. Now, looking at question 5, we've got 15j squared minus 9j plus 3. So we've got an expression and there are 3 terms in it. In this one, we're going to use the similar method to what we used in question 4, or I should say example 4, but we're going to apply it to all 3 terms. So looking at these, we ask ourselves, what is the highest common factor between 15, 9, and 3? And luckily enough, we're looking at it right here. It's 3. So 15 divided by 3 is 5. 5 is a prime number, so it's not going to get any lower than that. 9 divided by 3 is 3, and 3 divided by 3 is 3. So splitting this up, we're going to get 5 times 3, j squared, minus 3 times 3 times j, plus 3. Therefore, looking at what's common, well, we've got all of these 3's here. Simplifying that out, we bring the 3 out front. Then what we leave behind is a 5j squared minus 3j plus, and this 3, although we're taking it out, it's 3 divided by 3, so it makes it a 1. And therefore, we are in the most factorized form this number could possibly be in. So that's where we'll leave it for this video, and in the next video, we'll have a look at how to factorize trinomial expressions.